Dive into the world of ancient mathematics with one of its pioneers, Euclid. This eminent figure was active around 300 years BC, predominantly in the city of Alexandria, Egypt. Often hailed as the father of geometry, Euclid's work has left an indelible mark on the field of mathematics. His magnum opus, Elements, is a testament to his brilliance. This 13-volume work is a comprehensive compilation of the mathematical and geometric knowledge of his era. It's not just a collection, though. Euclid took this knowledge and built upon it, creating new theories and proving them with precise logic. His work, especially Elements, has been used as a foundational textbook in mathematics for centuries, underscoring the importance and relevance of his contributions. Now, having known the mathematician, let's delve into his famous theorem. Euclid's theorem, a cornerstone of number theory, is simple yet profound. This theorem, named after the ancient Greek mathematician Euclid, postulates that there are infinitely many prime numbers. But what does that mean, and why is it so significant? Let's start by understanding what a prime number is. A prime number is a natural number greater than one that cannot be formed by multiplying two smaller natural numbers. In other words, a prime number is a number that only has two distinct positive divisors, 1 and itself. Examples of prime numbers include 2, 3, 5, 7, and so on. Now, to the crux of Euclid's theorem. It states that no matter how many prime numbers we have listed or discovered, there is always another one that we have not yet found. This means that the list of prime numbers goes on infinitely, without end. It's like an eternal treasure hunt, where there's always another gem waiting to be unearthed. Think about it. The number line stretches infinitely in both directions. Now imagine that every prime number is a glowing point along that line. According to Euclid's theorem, no matter how far you travel along this line, you will always encounter another glowing point, another prime number. This concept might seem mind-boggling, but that's the beauty of mathematics. It often challenges our understanding of the universe and pushes the boundaries of our imagination. But why is this important? Well, prime numbers are the building blocks of all numbers. They're the atoms of the mathematical world. Every number can be broken down into a product of prime numbers. So, understanding the nature of prime numbers helps us understand the nature of all numbers. In conclusion, Euclid's theorem tells us that the world of prime numbers is endless. It's a testament to the infinite potential and wonder of mathematics, a field that continues to astonish us with its depth and complexity. And that, my friends, is the essence of Euclid's theorem. But how did Euclid prove this remarkable theorem? Let's find out. Euclid's proof of his theorem, often referred to as Euclid's Elements, is a work of pure genius. It's a testament to his extraordinary mathematical prowess. But don't worry, we'll break it down into bite-sized, digestible pieces. First, Euclid began with something we all know, a right-angled triangle. To prove his theorem, he constructed a square on each side of this triangle. Next, he looked at the square built on the hypotenuse, the longest side of the triangle. He noticed something interesting. This square could be perfectly divided into two smaller squares, each equivalent to the squares on the other two sides of the triangle. Now, if the square on the hypotenuse was smaller or larger than the two smaller squares combined, then it wouldn't match up right. There would either be space left over or not enough space. But it fit perfectly, like the final piece of a jigsaw puzzle. This observation was the crux of Euclid's proof. He reasoned that if the square on the hypotenuse is equal to the sum of the squares on the other two sides, then the lengths of the sides must also follow this relationship. And voila, the birth of the Pythagorean theorem, a theorem that has stood the test of time for over 2,000 years. But Euclid didn't stop there. He went a step further, explaining that this relationship holds true not just for one specific right-angled triangle, but for all right-angled triangles. No matter the size, no matter the orientation, this theorem holds true. Euclid's proof was so simple, yet so profound. It's a beautiful example of how mathematical truths can be discovered through careful observation and logical reasoning. A proof that does not rely on complex calculations or intricate formulas, but on simple geometric construction and intuitive understanding. And that, my friends, is the genius of Euclid's proof. Euclid's theorem isn't just a mathematical concept, it has real-world applications too. Now you might be wondering, where exactly would I use this theorem? Well, let's dive into it. Euclid's theorem, with its infinite number of prime numbers, is a cornerstone of number theory. This is the branch of mathematics that delves into the properties and relationships of numbers. particularly integers. Now, number theory might sound a bit abstract, but it actually has some very tangible applications. Let's take cryptography as an example. This is the practice of secure communication in the presence of third parties, and it's what keeps your online transactions and communications safe. In modern cryptography, prime numbers are used to create public key encryption systems. These systems are crucial for internet security, and they are built on the principles of Euclid's theorem. How does it work, you ask? Well, in basic terms, two large prime numbers are multiplied together to form a semi-private key. This key is then used to encrypt data. The fact that prime numbers are used is no coincidence. It's because of the unique properties of primes as outlined by Euclid that makes them ideal for this process. And it's not just in cryptography. Euclid's theorem has applications in many other fields too. For instance, in the world of computer science, it forms the basis of algorithms used for data analysis and machine learning. It's also found its way into physics, where it helps in understanding the properties of particles and fields. So you see, Euclid's theorem isn't just for mathematicians, it's everywhere around us. From securing your online transactions to powering the algorithms that recommend your next binge-watch series, Euclid's theorem has found its place in the world. It's a testament to the timeless relevance of pure mathematics and the genius of Euclid. And who knows, the next big application of Euclid's theorem might just be waiting for you to discover it. Let's recap what we've learned about Euclid's theorem. We began with Euclid, an ancient Greek mathematician who revolutionized the field of mathematics with his work, Elements. His theorem, a cornerstone of number theory, states that there are infinitely many prime numbers. This was not merely a statement, but a claim he meticulously proved, using a contradiction-based argument, showing us that if we assume a finite set of primes and multiply them all together and add 1, we get a number that isn't divisible by any of our assumed primes, hence leading to a contradiction. Euclid's theorem is not just a fascinating mathematical concept, but it has real-world applications too. It's fundamental to the functioning of our modern-day digital world, especially in cryptography, where it provides the basis for several encryption algorithms. And that brings us to the end of our journey into Euclid's theorem. Well, that was quite a mathematical adventure, wasn't it? We've journeyed through the mind of Euclid, touched on his theorem and even seen its proof and application. But remember, this is just the tip of the iceberg. Euclid's work spans so much more, and it's all waiting for you to discover. Take this newfound knowledge as an invitation to dive deeper into the fascinating world of Euclid and his mathematical wisdom. Reflect upon what you've learned today and ponder about its implications in your daily life. Got a unique perspective or an interesting thought? We'd love to hear about it. Share your insights in the comments section below. Engaging with complex concepts like these not only broadens our knowledge but also sharpens our critical thinking skills. So let's continue this journey of exploration together. Don't forget to hit the like button if you enjoyed this video and subscribe for more intriguing content. Until next time, keep exploring the world of mathematics.